Let's discuss the area of a triangle. The area of a triangle, any triangle could be made into half of a rectangle, and I literally mean rectangle. So it's actually half of a parallelogram, but that parallelogram can be made into a rectangle as well. So the area of a triangle is 1/2 times the base of the triangle times the height. And the key to this whole thing is that the height and the base are perpendicular. They form a 90-degree angle. So you can see how even if the triangle you're dealing with is not a right triangle, you can use some right triangle trigonometry maybe to calculate a height or a base or something like that. Okay, but I'm not going to focus on that here. I'm going to focus on the relationship between the base and the height and area of a triangle. So here I have a standard triangle. The base is so many units. The base is going to be the side on the bottom here, and these two lines here are parallel. So the distance between them is the height of this triangle, right? That's how tall it is from the base. So you'll see I've got the area of the triangle down here. It's 13.5 for this particular triangle. And even if I move my top point, the base is staying the same, notice, and the height is staying the same. My triangles all look different. These are all different triangles. The base and the height are the same, so the area is not changing. So all of these triangles have the same area because the base length and the height length are the same. Okay, so this is rather interesting. So now how do you set up the relationship between the base and the height? So the first thing I want to do is take a simple example of a triangle, an acute triangle where all of the angles are acute, potentially, maybe something like this, and I'm going to make 3 copies of it. And what I want to do in each of these is choose one of the sides to be the base. So I'm going to choose each side to be the base for each picture. So the first picture, I'm going to choose the obvious side to be my base. So the red side is going to be our base. Here let's choose maybe this side to be our base, and here let's choose this side to be our base. Okay? So let's call this b sub 1, this b sub 2, and this b sub 3. And what I want to do is show you how to establish the height of the triangle relative to the base you choose. Well, in the first case, it's pretty simple. From the base, I need to find the furthest point away to get my height. So the furthest point away on the triangle is this point. So my height is this perpendicular distance. See how they're perpendicular to each other? So we'll call this height 1, h1. So I could use 1/2 times b1 times h1, and that would give me the area of this triangle. Over here, if my base is this red side, the point on the triangle furthest from that base is this vertex. Okay? So the height is perpendicular to the red line and connected to this vertex. So it might be something like this. So this we might call height 2. So 1/2 times base 2 times height 2 would give us the same area as if I calculated using these bases and heights. Finally, the last one, the point furthest from this base is this vertex. And if I measure a perpendicular height from this vertex down to base 3, this would be the height that I would work with. So we would call that h3. So you could calculate the area of this triangle any of these 3 different ways. And you can see how you get right triangles when you do this sort of thing. Let's take another example. Here's a triangle. Let's say that this side, the bottom is the base. Let's choose the natural choice. If this is the base, then how would you measure the height? Well, this one's a bit trickier because of this obtuse angle. The point furthest away from your base, highest away, is actually this vertex over here, which doesn't lie over your base. But that's no problem. You can extend your base as like an axis to measure your height. So you can extend your base so that it lines up with your vertex, and then you can drop a perpendicular line to get your height. So this would be the height of this triangle measured outside of the triangle, but yet you get a 90-degree angle that's perpendicular to your base.